Listen to part of a lecture in a geology class.
Last time, we started to talk about glaciers and how these masses of ice form from crystallized snow. And some of you were amazed at how huge some of these glaciers are. Now, even though it may be difficult to understand how a huge mass of ice can propel itself, glaciers do in fact move, or flow is the other word for it, and I'll tell you how. The first type of glacier flow is called basal slip. Basal slip, or sliding as it's often called, basically refers to the slipping or sliding of a glacier across bedrock, actually across a thin layer of water on top of the bedrock. So this process shouldn't be too hard to imagine. What happens is that when the ice in a glacier is under pressure, the pressure could come from the overlying ice or an obstacle in the path of the glacier, but for whatever reason the ice is under pressure. And you probably know that under pressure, the melting temperature of water, of ice I mean, is reduced. So ice at the base of the glacier melts, even though it's below 0 degrees Celsius, and this results in a thin layer of water between the glacier and the ground. This layer of water reduces friction. It's like a lubricant, and allows the glacier to slide or slip over the bedrock. Okay? Now, the next type of movement we'll talk about is called deformation. You already know that ice is brittle. If you hit it with a hammer, it will shatter like glass. But ice is also plastic. It can change shape. If you leave a piece of ice supported only at one end, the other end, the unsupported end, will deform plastically under its own weight. It'll kind of collapse at one end, get distorted, deformed. When pressure or stress is put on a glacier, the glacier reacts by reorganizing the ice crystals within it. During this reorganization, the ice crystals realign in a way that allows them to slide past each other, allowing the glacier to change its shape and move. And there are a couple of factors that affect the amount of deformation that takes place, or the speed of the glacier's movement. For example, deformation is more likely to occur the thicker the ice is, because of the gravity of the weight of the ice. And temperature also plays a part here, in that cold ice does not move as easily as ice that is closer to the melting point. In fact, it's not too different from the way oil is, thicker at low temperatures. So if you have a thick glacier in a slightly warmer region, it will flow faster than a thinner glacier in a cooler region. Okay, I'd like to touch briefly on extension and compression. Your textbook includes these as types, as a particular type of glacial movement, but you'll see that there are as many textbooks that omit it as a type of movement as included. And I might not include it right now if it weren't in your textbook. But basically, the upper parts of glaciers have less pressure on them, so they don't deform as easily. They tend to be more brittle. And crevices can form in these upper layers of the glaciers when the glacier comes into contact with bedrock walls, or is otherwise under some kind of stress, but can't deform quickly enough. So the ice will expand or constrict, causing big fissures, big cracks to form in the surface layers of the ice. And that brittle surface ice moving is sometimes considered a type of glacial movement, depending on which source you're consulting. Now, as you probably know, glaciers move really slowly, although they sometimes experience surges. And during these surges, they can move at speeds as high as 7,000 meters per year. Although speeds like this are pretty unusual, they're hundreds of times faster than the regular movement of glaciers. The movement of glaciers can actually be observed during these surges, although it's rare.